Are you familiar with LEDs? There are many colors beyond the basic red, green, and blue. How exactly are LED colors created? Let's explore LEDs, which go beyond simple diodes together. First, let's briefly understand the principle of LEDs. It is a component that adds a light function to the diode function. Like a diode, it allows currents to flow in only one direction, while simultaneously emitting light. This is used to visually display light in electronic products. Expanding a bit further, it is also used in LED street lights. The range of light we can see with our eyes is the visible spectrum. There is a characteristic where the intensity of energy gets stronger as you go from red to blue. The principle of the light emission is that electrons release some energy in the process of stabilizing. At this time, the released energy is converted into light. More details on this can be found in my previous videos. The three basic elements of color are RGB. How is this implemented? I will explain the difference between the textbook principle and the modern process by describing the layering process. First is the textbook principle. The first layer contains the N-type semiconductor. Phosphorus is mixed into pure silicon semiconductor. Combining a group 4 element and group 5 element leaves one extra electron. This creates an N-type semiconductor carrying a negative charge. The second layer is called the active layer. This is the critical layer that determines the color of the LED. For red, gallium and arsenide are injected. For green, gallium and phosphorus. And for blue, gallium and nitride. Boron is mixed into the silicon semiconductor. Combining a group 4 element and a group 3 element creates one electron hole. This creates a p-type semiconductor carrying a positive charge. LEDs of three colors are created. Next, let's look at the modern process currently in use. When making the N-type semiconductor, gallium nitride and silicon gas are mixed. Next is the active layer. For blue, a small amount of indium is added to gallium nitride. For green, a large amount of indium is added to gallium nitride. For red, the tracer method is often used due to efficiency issues, but in other methods, a very large amount of indium is added to gallium nitride. When making the p-type semiconductor, magnesium gas is mixed with gallium nitride. The differences can be summarized as follows. How are other fancy LED colors expressed besides the three primary colors? The simplest method is to bundle the three LEDs mentioned above and turn them on simultaneously. In this way, colors like cyan can be created by color mixing, just as turning on red and blue LEDs simultaneously creates magenta. Another method is to cover a blue LED with phosphorescent powder of a specific color. For example, covering a blue LED with orange phosphor creates orange light. In this video, we briefly look at the process of how LED colors are created. Next time, I will make a video about optocouplers. If you liked the video, please subscribe and like button. Thank you for watching.